Welcome back to the edspread. Now today in the SQL bootcamp, today we are going to learn about the basic structure of the SQL, the set operations, and some of the SQL rules, and then we are going to learn about the aggregate functions that are possible in the SQL. So let us start with the basic structure of the SQL. The fundamental structure of the SQL queries include three classes that are select, from, and where. See, the queries means anything. The queries also mean create, insert, update, delete, the DML commands, the DML commands, and the DDL commands, the DQL commands. Everything that we have learned, everything comes into the query. Now, if we want to retrieve any data, these three are 100% used. If you want to retrieve any data, the access to any data, these three, the select, from, and where clause is used. So where do we use the select, from, and where? I guess on the day one or the day two, we have learned. I have shown you the select clause where it has been used using select star from EMP or something like that with only one row. But in the same way, we can whichever columns though. So how we are going to write it is select. So in the same EMP database, employee database that I have shown you yesterday, select I guess you know the select attribute. Okay, attribute 1 comma attribute 2 comma. Okay, there are some mistakes from my side. Attribute 2, attribute 3, and so on. And from table name. Okay, no, these are okay. Wait, from the table name and where we write the condition. So this is how we are going to write the select clause. So this is okay. This is how we write the condition. Now, for example, we want to select all the attributes. Select all. Now, if there is employee that I've already written before, and all the all the rows, all the tuples have been inserted already. Now I'm going to write it as select all from EMP, where, let me write, if I want to get, now you know the table, right? These tables have different department numbers, where DPT number equal to only 30. So department number is a number, so I don't need to write the codes here. So this is how I'm going to write if there is any, all the tuples have been inserted in the database. So this is how we are going to write it. Select all from EMP where department number is 30. So where department number is 30, or we can write any other condition like where job equal to only manager, where job equal to only manager, where job equal to only manager. I want the information only about the managers who work in that particular company, in that particular this thing. Or this is about the EMP table. If not in the EMP table, I can also write from the other table, that is nothing but the department table. And in the department table, let me write the location. The location is always, if the location is New York, then I want that. Okay, that particular row will be selected to me. Okay, if I don't write this condition without the where condition, all the rows from the department table will be displayed to me. So on which condition should the data be evaluated and shown to me, on which purification the data needs to be purified. I don't want to see everything that is possible, every row, or else that will be very confusing to me, right? So here we are going to do only with a condition that is nothing but the where condition. Okay, I've deleted it somehow. Okay, the where condition, where, and I'm going to write in the department table, right? So where location is also, where location is something. Okay, from department where location is something, I'm going to write like something like this. So this is how the select from and where. If the data has to be retrieved, select from and where is compulsory. Where is not compulsory. You can say it as optional, but all the data is not useful to us. Only some data with the condition they'll ask in the questions, in whatever questions you see, those will be required. So the where is optional, but we are in 90% of the cases, until and unless we want all the columns, we are not going to use where. Okay, we are not going to use where if we need all the columns. If we need only some columns, then we are going to use the where clause. And once you get this, the select from and where, I'm going to read the definitions that are present here. Select whichever columns we want. If we want the all columns, then we are going to use the asterisk that is there in your number keypad on the right side. Okay, on the upper side of the 9. So the asterisk can be used, or the using shift you can press 8, you can get the asterisk. And that is about the select clause from which relations. See, the entities and the relations we need to access the data, you need to specify in the from clause and then the where clause. Now the how the relation must be operated to get the result is specified. See, we don't need the all column, so that's what we're going to write in the where clause. So the format I've written it again here. The select the attribute names from the we can get the table from more. We want to compare two things. For example, in the EMP database, if you have seen yesterday, if you haven't seen properly, see it again. Now, if we want the table names, with the department number, there is some locations with these department number. The places that they work is limited. There is only one location with this particular department number. So I want to map all of them. So I can map them. So something like that means I can take the columns from more than one table. So we can write comma and we can write the second table also. So the second table and where the condition, I'm going to write it here, and the conditions. Okay, as you can understand, the select we can take more than one attribute also. The from we can also take from more than one table, and where we can also write two conditions over here, where two conditions, where department number equal to 20 and his name is equal to Jones. So 2 or 3 conditions we can write here. So select from, and to understand P1 comma P2, etc. It can go on. Okay. So at the end of every query, we usually write a semicolon, and then in a live SQL, it doesn't show any error. If we are going to run when you are going to run more than one, then if we want to run something like this select clause and this select clause, we want to see the data at only one time, the both of them. Then to differentiate the first and the second query over here, then 100% we need to have one. Else, if we are executing only one, then we don't need a semicolon at all. We don't need a semicolon. Only then with these without the semicolon also we can run, we will not get any error. But in some cases like MySQL and other which deal with the DBMS will give us an error if there is no. And if you are using HackerRank, there will get an error that the semicolon is not present. Okay, so that will be an error. So it's better whenever you're writing a query, it's better to have a semicolon at the end of every query. Okay. So in the what I've written is, in the select clause, you have to specify the attributes that you want to select in the result relation. Yeah, you have got it, as I said you here in the previous slide. And in from clause, you have to specify the list of relations. Relations are nothing but the entities or the table names that has to be accessed for evaluating the query. And in the where clause involves a predicate that includes the attributes of the relations that you have listed from the clause. We want any particular condition, then that particular thing that needs to be mentioned in the where. Okay, this select from and where we call, we call these as clauses. Okay, so because you know what is subject and clause, right? I'm not going to go into the English thing. So this is it. This image was also there in the previous slide or day before yesterday. I've shown you this. So any SQL query will be gone to the query language processor that includes the parser and the optimizer. I'm repeating this again so that once you get the whole idea, you'll be able to practice. Okay, now how was this processed? Everything, the DBMS components, I guess that is the heading of the previous, the day one or the day two slides. So the DBMS engine has a file manager and the transaction manager. The file manager is nothing but the data is present in the file manager, and the transaction manager is nothing but the whichever operations, which are the conditions that we are going to do in the transaction manager. That is everything that will be done by the DBMS engine, and the physical database that at the end of the resulting database will be affecting here. Whichever the SQL query, the same process will be done, and in some cases, if you are storing the data, then the file manager and the transaction manager, everything will be going from here to here. So there should be an arrow here. So that is how this particular query and everything works. And next, coming to the SQL rules. So the SQL is nothing but the structured query language. I said you about this in day one, and it is not case sensitive. And see, on the day one or day two, I've shown you that however you write the query. See, I'm going to take the caps lock again. So it will be recognized. The color of the select will be changed. See, again, I'm going to write all of them. Okay, I'm going to write one lowercase and one uppercase just to show you that there will be, however you write it, they will be recognized and the color will be changed. This is not the other, the Java or C, these are not case sensitive, whereas the DBMS, for our comfort, this is case sensitive. However, you're going to write the words, it is going to recognize. And in the same way, even if you write the table name, everything, if you have written in the create table, you have written with the lowercase, and when you're taking the query, you have taken in the uppercase or something, like if you have mixed both this uppercase and the lowercase with something, or toggle case where the first letter is small and the all letters are big, even then we are going to get the query without any error. Okay, it is a very comfortable feature in the SQL that I usually use. I'm going to mix all the letters. Once I'll use with lowercase, I'll use with uppercase, whichever and whenever possible. And I've shown you here most of them with the uppercase formats only. Now, generally, keywords of SQL are written in the uppercase. It is a general format. It is a kind of tradition. And in the same way, I usually write it in the uppercase itself. And the second rule is statements of SQL are dependent on text lines. We can use a single SQL statement on one or multiple text line. Okay. And see, many people have shown you the select from and where in 3 lines. Okay, 1, 2, and 3. Now, many also write it like this, from, and we can write where also like this. See, this whole is one query. So I can, even if I write it like this, it is going to work. And even if you write it like this, it is going to work. As I wrote before, like this also it is going to work. But many people suggest this particular way of writing in 3 lines, because wherever you have a problem, in whichever line, sometimes you'll get the line number where you have the problem, that will be shown. And if you write the wrong table name, if you have the long query, something like this I have shown you before, it is hard to recognize where the problem is. So many people say you to write it like this itself, the select from, where, group by, order by, having by, everything else, group by, having by, I'll show you tomorrow on how to do that thing. All these clauses will be usually written the one line after the other line. so that to reduce errors, to avoid errors, and to easily debug where is the problem. And it is dependent on text lines. Many write it in one line, and it is better to write it in 3 or 4 lines. Okay, one or multiple text lines, and using the SQL statements, you can perform most of the actions in the database. Yes, you have understood this, I suppose. And coming to the next one, SQL depends on the tuple relational calculus and the relational algebra. That is all about the relation state, whatever we have, these primary key, the foreign key, the unique key, not null, everything. These are all depending on the relations that the data has been compared to, and if the data is not being satisfying that particular condition, that particular constraint, then we use then it is going to throw an error. So it is all about the relational calculus and the relational algebra. Okay, now the next slide. Now, before I come to this slide, let me give you about the sets first. Now, I'll give you some idea about the sets, and then I'm going to tell you about the set operations. Now, I'm going to write everything in this in comment, as this has nothing to do with the query, or I'm not going to run it. Okay, so yeah, 18. Okay, now let us now set is a set of numbers which do not contain any sequence or which do not have any logic between them. They are just few unrelated numbers which belong to with some particular relation they have. For example, all these, let us set of the even numbers. So the set of even numbers consists of 2, 4, 6, 8, 10, 12, etc. Okay, this is about the set A, and set B consists of the odd numbers. Okay, set B consists of the odd numbers. The odd numbers include of 1, 3, 5, 7, 9, and 11, and goes on. The list goes on. Now these are two different sets. Now, if I write A union B, okay, union B. Now, union is nothing but the set of numbers that includes in A and as well as in B. Now, in this case, A union B, it is going to be all the natural numbers. That is 1, 2, 3, 4, 5, 6. Now, many people might not have an idea about these sets and unions, intersections, and everything, and the set difference. But I'm just going to show you what these union except these all things: 7, 8, 9, 10, 11, and 12, as I've written about till 12. Now the list goes on. If it's infinity, then it goes until infinity. It consists of all the natural numbers, A union B. And means here what you're going to understand is whichever both the things in the set A, whichever elements are there, those elements should be present here, and whichever elements are present in B, those elements should be present here. So that is what you need to understand. And next coming to, I'm going to take another two sets, C equal to, let me take 1, 2, 4, 5, 7, 8. Okay, and let me take a D, set D. And this is how we notate it. We write it in the flower brackets to say it's set. And let me take it as the set D has 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I have not written commas, or else it will be a 9-digit number. That's my mistake. Okay, so yeah, these are the numbers. I'm in the wrong place. Yeah, these are the numbers. Now, if I need to write C union D, C union D will be 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, because it includes all the numbers that should be present in C as well as in D, and you shouldn't repeat any element. If the element is repeating here, see, the 1, 2, 4, 5, 7, 8 are repeating in both. but we write it only once. So that will be, see, we will write it only once. So it will be the same elements 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is what I'm going to paste here. The C union D, these will be the elements. And now I'm going to show you about the intersection. Intersection is nothing but the common elements in both will be a part of this intersection. Now the common elements in both are 1, 2, 4, 5, 7, 8. These are repeating in both the elements. So the union will be only these elements 1, 2, 4, 5, 7, and 8. So this is will be a C intersection D. Okay, we for A union B, we usually denote it with U. Many people denote it with U, and if it's an intersection, many people denote it with a reverse U. Okay, you will be able to learn in this part in also mathematics. I guess you have learned it in 9th or 10th classes also. So this is about the union and the intersection, and this is about everything is about set operations. Reverse U, I guess there is no how we can write it on a keyboard. No, I'm not going to show you this. For intersection, you can write a reverse U. I'm just going to write it in case you forget it. Reverse U, and coming to the third set operation is X as set difference. Now set difference is something like, okay, the set difference is something like, if there is, let me take these sets itself. Now this is set A, right? So this is set A, and let me take set C. So this is set C. Now these are the two sets. Now if I write the set difference, as the word difference means the subtraction, we use it in math. So set difference means the difference. So set A minus set C. So this is how we are going to denote these, or else this set difference. Okay. Or in our DBM's language, we write A except C. Okay. So that will be, so the elements which are present here, see 2, 4, 6, 8, 10, 12 minus these elements. Okay, so the 2 element is present here. The 2 element is also present here. So we need to subtract this element. This element shouldn't be there. Okay, so the 4 can be there. You first need to see the 8th element, 8th set. Now you need to set if these are here, we shouldn't write them. Okay, we shouldn't consider them. So A minus C. Now again we have 4. 4 is there here also. We shouldn't consider it. Now 6 is there. Now 6 is not there in set C. So we are going to write 6 here. 6 and 10. 10 is not there in the set. So 10. Again 12. 12 is not there in set C. So 12. And this again 14. 14 is not there in set C. Now this is a set of even numbers, right? So this goes on. So A minus C, these elements which are present in A and not in C. And A except C is not equal to C except A. Now if I write C except A, okay, now this is a mistake. These sets are always denoted by capital letters. C except A, no, C except A is nothing but, first you need to take the elements in C. So 1 is not there in A, so I can write 1. 2 is there in set A, so I cannot write 2. 4 is there in set A, I cannot write 4. And 5 is not there in set A, so I can write 5. And 7 is not there in set A, I can write 7. And 8 is there in set A, so I cannot write 7. So C except A is different from A except C, and you need to be aware of it, and you shouldn't be confused. So these are the 3 set operations that are possible in the DBM's language. So here, now A except A, or you can write it as A minus C, or here for this, you can write it as C minus A. This is what the operation that we are going to do. Okay, in maths, you have already learned it, and if you have not, you have revised the topics. So this is about the 3 things that you need to learn about: the union, set, the union, intersection, and the set difference. Now, how we are going to use this and where we are going to use this set operations. Now, okay, these are the examples. Now I don't have any queries or the data on which I can perform these. So I have taken these from the net itself and some from the textbook directly. So this is in a university database. Now there are some courses, and this is an American thing. So some start in fall and some start in spring, and that ran in fall or in. Okay, now if the word is there is or, it means union. Means or is nothing but it should be either there in this. Now if there is an element in A union B, what does it mean? The element is either there in A or in B. That is for sure, right? Either A or in B. Okay. So it is or. Or means nothing but union. So you need to write union. Okay. So the table name here is a section. So from section where semester equal to fall and year equal to 2017. As there are, I said you here, right? There can be more than one condition where you can write this thing. More than one condition you can specify over here. So as in this particular thing, it should be in fall and it should be in 2017. There are two different columns. There are two different columns in the table section. So in the table section, the semester, SCM, when it has started the semester, and the year are two different columns. On those particular columns, we want to select the course ID. Okay, the question is find courses that ran in 2017 or in spring 2018. So we are going to use select course ID. We want only the course ID. So in the university database, the course ID is nothing but every course that you have done in the semester will have a particular ID, and which has some particular syllabus with any number of units. So we are going to select the course ID from the section where there are two conditions, that is semester and year. We are not going to write a comma here. We are going to write end. This is a thing that need to be remembered. We are going in the where clause. You are not going to write a comma here. If there is a comma, it is an error. We need to write end because both of them needs to be done. Okay, both of the conditions need to be satisfied. So semester fall and year equal to 2017, and union this select clause where semester equal to spring, the spring to or in spring 2018. So as it is or, we are going to or means either in one or either in two. Both of them we need. So union which fall in spring and year 2018. So that is how we are going to use the set operations, the union here. And the next thing is find the courses that ran in fall 2017 and in spring 2018. So this is how we are going to write. Now the thing that needs to be understood here is we wrote the word end. So end is nothing but for the intersect, means. Okay, let me come here and show you with an example. Now here we have seen the intersection. Okay, now these from 8 to 12, it is the intersection. Now here what you are going to understand is C intersection D. Now let me take it for a minute. Let me take this. Okay. Now C intersection D, the element 1 is there in D and as well as in C, right? So see, whenever I'm selecting this, there is a small box here that is provided by the live SQL that will help us. So the one that is already there in the set C and set D, and 2 that is already there in set C and as well as in set D. The 4 that is already there in set 4 and set C and set D. So we are going to write the elements which are present in both at the intersection. So here the terminology that you're going to use is end. Whenever end is used, we are going to use intersection. So with intersects which are there in both of them, only then we are going to take. So select course ID in fall 2017. Those are the two conditions. semester equal to fall and the year equal to 2017, which intersect means which both of these conditions need to be satisfied. In this case, either one of them, this case or this case, the first set, either the data that should either be in the fall 2017 or in spring 2018. Okay, both of them will be specified. Okay, here either in it should be in either it should be both in A and as well as in B. So in the same way, the spring 2018. So as you must have understood by now, but I'm just repeating it. If that is in double quotes, it means the varchar has been used over there. So varchar, and it is a string in fact. So this single quote should be used, and we never usually use double quotes in the SQL language. And if you are not writing any quotes, I mean from the queries, I'm saying you from the we are coming from the back. But whenever we are going to write a varchar in the creation of the table, it means we need to write the single quotes. And if we are mentioning an integer or a number, then we don't need to write any quotes. Okay. So the select quotes ID intersect the select quotes ID from where spring and year. So that you have understood. And now coming to the set difference, where the set difference but not in. Okay, it should be in one, but not in the second one. So we are going to use the word except. The word except because the set difference, I've written it here. Now in the set difference, you see, it should be in A, but it shouldn't be in C. So, but not in has been used in the terms. And here, as I wrote, A except C means it should be in A and it should not be in C. And we should always start with the term that is first present here. The A except C means first we are starting with A and then we are looking with C. So in the same way, 6, 10, 12, 14, etc. And C except A means we are starting with C. So that is how we are going to do. Okay. C except A means first we are starting with 1 here. See 1 and then 2, 4 is already present, so we have written it 5. Okay, I'm not going to repeat it again. I'm sorry. So C except A, and the word that is present here is but not in. Okay, so but not in will be there in the question. Then we're going to use except. Okay, so yeah, that find courses that ran in fall 2017, but not in spring 2018. So select course ID from section where semester equal to fall, the two conditions, and there should be mentioned with and year 2017, and except select course ID from section where semester equal to spring and year 2018. Means it should be in 1 and it shouldn't be in 2. It should be in set A, it shouldn't be in set 2. It should be in the query 1 and it shouldn't be in the query 2. Okay, these are the set operations. And now we are going to learn about the null values. So yeah. So about the null values. The null values is something. Okay, you have learned about the null constraint first. So let me, after this comment, I want to write. So null constraint I have understood. So what is about this not null constraint? Now with the word null, there is a constraint not null that I was shown you yesterday. Now, okay. Now if there is any particular column that shouldn't be left as null, that shouldn't be empty, then we are going to write the not null constraint when we are creating the table. Now, what is this null thing? Null value. Now, what is null value? Means leaving the column empty. Means leaving the particular input value that we are entering into the table, that we are entering into the column is empty. When you are inserting the value, if that shouldn't be left null, we are going to write not null constraint. Now, what is being null? About the null values we are going to learn. Okay. So here it is. It is possible for tuples to have a null value. See, if we don't write a null thing, and if it is not a primary key, then it can accept null values, right? If it is as I said you before, I'm repeating it again as it is important. The primary key will have the unique values which will help us to identify that particular tuple. And the next important point is it will not accept the null values. So if we don't write while creating the table for a particular attribute, if we don't write the primary key, and if you have not defined it is denoted not if there is no not null constraint, then it can accept null values, right? That is what it has been written here for some other attributes. Okay. For some other attributes means for other attributes we have primary key or primary key. There are no other constraints as primary key, unique constraint, or something like that. So the null signifies an unknown value or the value does not exist. For example, now there will be some operations that I'm going to learn, say about tomorrow or the day after. So when we are going to add to 5 plus null returns as a null, means tomorrow I'm going to say you about the joins. So in the joins, you'll get to know where are we going to use these with the null, what we are going to do and the operations on it and how it is going to matter. It is also an important part because we need to use the null values too, and where will we get a null value. Tomorrow in the joins part, you'll get to understand. Okay. So here in the employee database, we have given the salary. We cannot take the we have used a check constraint where the check constraint is always greater than 500 or 500. The check constraint I have written as greater than or equal to 800. With the same thing here, the predicate null is also used in the select query also. It has been used. See, select name from instructor is nothing but a teacher here. Okay, from instructor where salary is null. Okay, where salary is null, those particular tuples, that particular tuples has to be selected. It means that there are some new recruits and the salary is null for some people where the salary has not been assigned, so it has been left null, and there is no particular constraint in the when the table has been created that the salary cannot be null. So it has been shown that the salary is null. So those tuples where the salary is null, it should be shown. Okay. The predicate is not null succeeds if the value is applied is not null. Okay, that it is common sense that the last point is there. And next, continuation. So the SQL treats unknown values of any comparison of any null value other than, for example, 5 is less than null, null is greater than or equal to null, null is greater than, less than, or equal to null, or null is always equal to null. According to the condition, these will particularly run. Next, coming to the next part, the predicate in a where the predicate in a where clause can involve the Boolean operations and or not, and thus the definitions of the Boolean operations need to be extended to deal with the unknowns. Okay, true and unknown. Unknown is nothing but a null value. Okay, here it is written. True is nothing but the unknown value. Signifies an unknown value. Instead of writing a null here, I wrote it as unknown value. So true and unknown is always unknown. Okay, false and unknown is false, and unknown is unknown. Unknown or true is true, unknown or false is unknown. Unknown or unknown is unknown. Okay, this is how the null values will be treated. And the main part of this null values, I have written a query over here, but the main part will be important in the joins. So first you need to understand this, and then the next part that you are going to learn today is the aggregate functions. The aggregate functions, these are the aggregate functions that are possible. Now these are the 5 aggregate functions. Now there are other advanced aggregate functions that we are not going to touch about, which is in the part of advanced SQL. Now we are just going to learn about the basic SQL and intermediate SQL. The advanced we are not going to teach now in this week. So these functions operate. So the aggregate functions. Now these functions operate on the multi-set of values of a column, relation, and return a value. So these are the things: average, minimum, max, sum, and count. So these are the 5 aggregate functions that are possible. So they are, so you might have been using the average and sum. I guess you know the meaning of these at least these two terms. Now coming to these, average is nothing but sum of all the numbers by the number of numbers. Now we use this average function. If you remember, we can use this average function in Excel sheet, where you write average of some numbers, these columns with these rows, we can write the average. And in the same way, the sum also can be written, and you must have experienced it or seen it before. So average, sum, average and sum, 100% you have seen it somewhere. So sum of values. So for example, here in the employee database, we are working on an employee database. For suppose now if I want, now for example, I'm going to say you, now I'm the boss of a company and I'm going to give money for some people. I mean, obviously I need to give the salary to these employees, and keeping in mind the database that I've created it, yes, the database. Now I can write it as select. Okay, it is still in comment, so I'm getting it in green. Select. Okay. Select sum of, I mean, how much I need to pay the employees, how much am I paying the employees. Select sum of sal from EMP. Right. If I write the sum of all the salaries, then it will return me the salaries. Okay. That is how we are going to write it. And tomorrow I'm going to show you how these are going to work. Okay. Now I can just give some particular function on how these can, I mean, instead of writing the aggregate function, I can write this, but instead I'm going to write it like this. Okay. The sum you have understood. Now the average income of the employee, now that can also be found out in the same way. Sum, select average, A, V, G. Yeah, A, V, G. That will be selected as average. So that is how I'm going to write. Okay. See, again, I forgot to write it in capitals. Okay, so it is better to write in capitals, and also use the min, max, and count. So min and max, again, on this in the same way we can write it. See, the select minimum of the salary, the minimum salary that I'm giving, and in the same way the max of the salary that I'm giving. Okay, everything that is possible here. So the max of the salary is present here, and now coming to the count. See, the number of employees that I'm working, that I've shown you on day 2 on Tuesday, are we do not have a column known as index or serial number. So we do not know the number of columns most of the times. So I can write select. Okay, I'm doing the same mistake again and again while writing the select count of, count is an aggregate function, count of, let me write it as EMP ID. Okay, you can count EMP IDs, or you can count EMP name. It is your choice. From the table EMP is the table name. So EMP. So if I run this, we can get the answers. We can get the number of employees that are working. If I get the number of employee IDs, that is nothing but the number of employees working in that company, working in my corporate. Okay, so that is how we are going to write the count function. And coming to some of the example that I've written about these aggregate functions. Select average of salary from instructor. Now again, this is about the university database. So instructor, as I said you before, that is nothing but the teacher who's giving the instructions to the students. So find the average salaries of the instructors in the computer science department. Now there is a condition. Now whatever I shown here, there is no particular condition. I want all the employees. So I'm not writing any particular condition here or here. So here I am mentioning it as a computer science department. So So the department name is an attribute. So where the department name column, where the department name column, then there is a tuple value in the department name as computer science. Those have to be selected, and the average salary should be given. Okay, tomorrow I'm going to show you all these with an examples with the database, everything created. So as there is no database that I'm presently working on what I'm showing you, that I've not inserted any values in these two tables. So I'm going to show you tomorrow on how to do these. And also tomorrow we are going to see some complex queries on these particular things using all of them, using the aggregate functions and the select from where, and also some important things like group by clause, where clause having not group by having clause, etc. And some sub queries also I'll try to cover it tomorrow. So please don't miss tomorrow's class, tomorrow's day 5 of the boot camp. And see here, who teach a course in the spring 2018 semester. You select count. So count is used like this. Select count distinct ID from teachers where semester equal to spring and year equal to 2018. So thank you guys. This is the end. So please don't try to miss tomorrow's class. Like, comment, share, and subscribe to edspread. Thank you, everyone. That's it for today, guys. Let's meet tomorrow again. Do not forget to like, share, and subscribe. Don't forget to fill the attendance form, which is posted in the chat box and even in the description. Join all the groups that are all the links that are in the description below. Thank you.